Let's do an example. Suppose we have a transformation t of x equals ax. Now A is a matrix, so that means this is a matrix transformation, right? Now, we're not told what matrix A is, but we are told A times vector u, if we do the matrix vector multiplication, is vector 3, 2. And we're told that A times vector v is negative 3, negative 5. What we want to do now is find what the transformation of 5u minus 3v is, right? So even though we don't know matrix A, we can still find this because we know enough. We know what A of u is, we know what A of v is, so we can find this using linearity. So the very first thing I want to point out is A of u, that's just equal to t of u, right? T of u is equal to A times u. And A of v, well, by definition, A of v is just, A times v is just T of v. All right? So if I want T of 5u minus 3v, what I could do here is use the linearity of a matrix transformation. So I know that T of 5u minus 3v, I can split it up over the addition. All right, so I had the sum of 5u and negative 3v inside here, but because of linearity, I could split it up so I have a transformation of the sum of two transformations instead of the transformation of a sum. Okay, and then also by linearity, I could pull out the scalars. And so I have 5 times T of u minus 3 times T of v, and I know what T of u and T of v are, right? By definition, T of u is A times vector u. T of v is A times vector v. And I'm told that A of u, A times u, is 3, 2. Vector 3, 2. Minus 3 times AV, and matrix A times vector V is negative 3, negative 5. And from here, it's just straightforward vector operations. So if I do the scalar multiplication, I get 15, 10 for the first vector, 5 times 3, 2. For the second vector, I'm going to get negative 9, negative 15. And if I subtract them, 15 minus negative 9 is positive 24. 10 minus negative 15 is positive 25.